Hey, graphing linear functions. So linear functions are straight lines that sometimes have a slope, sometimes they don't, but they have evenly spaced x values and evenly spaced y values. So here they talk about a hurricane, all right, which we had a nasty one just recently with Sandy hitting the East Coast. And over time, we have distance from land, so it was traveling at a linear rate, okay, getting closer and closer to land. Okay. So we're going to talk about linear functions, and the biggest part is that all linear functions, that we want to write them in the form f of x equals mx plus b. And we're going to use that form a lot, not just y equals. But a reminder that that is basically similar to y equals mx plus b. Right? What's m stand for? The slope of the line, okay? And b is the y-intercepts. Okay, good. So first thing we're going to do is, given a set of data, can we determine whether it's a linear function? Or we want to figure out if it's a linear function. So what am I looking for? Does this relation represent a linear function? And how do I know? What are we looking for as far as the x values? What must be true about them? What? They have to be constant, okay? So they have to have a constant rate of change. So I want them to be going up by ones or going up by twos or going up by threes, okay? All right, so here we have this one, they change by 2 each time. What about our y values? What do we want those to do? Dylan? Okay, we want those to change at a constant rate also. And here, each of these change by -1. Okay. So since the first difference are the same, then this would be a linear function. Anybody tell me what the slope is then? What's the value of m? All right. Well, it's -1/2. Right? We'll talk about more about why it is in a minute. All right, but it's -1/2. Change in y over the change in x. Okay, I'm going to give you the assignment now before we do this other problem, since Morgan. Okay. All right. Letter B. Does this set of data represent a linear function? So we want to look at the x values. Do they change at a constant rate? Okay. And they do. They're all changing by 1. Then we want to look at the y values, or the f of x values, and do they change at a constant rate? Okay. So we can find that out by doing the differences. So the first difference, so we're going to subtract all of these, starting with the farthest one down and working our way back. 16 minus 8 is 8. 8 minus 4 is 4. 4 minus 2 is 2. Since those are not the same, this is not linear. So the x's have to change at a constant rate, and the y's have to change at a constant rate for it to be a linear function. Okay? Otherwise, we won't get a straight line. Right? This would be exponential. All right, graphing lines. Okay, now we mentioned the word slope. Slope is here. We can think of it as change in f of x over change in x, or the change in y over change in x. Okay, that's the slope. Okay, or you might think of it as rise over run. Now, the one thing is that whenever we're graphing, okay, when we use the slope, okay, the rise it either may rise or fall, okay, depending on whether it's what? Positive or negative. But when we run, we're always going to run to the right, okay, in the positive direction. Right? Okay, so here we want to graph the line with a slope of 5/2 that passes through the point -1, -3. How many of you already know how to do that? Okay, all right, good. All right, everybody but Alex. Okay. Okay. So when I'm graphing this, do I graph the slope first or do I graph the point? Okay, so we have the point -1, -3. We'll graph that point. And then the slope, always we're rising or falling first, depending on whether it's positive or negative. And then we're always going to run to the right. So it's 5/2, so I'm going to go up 5 to 2, and then over 2 to the point 1, 2. And then we will draw our line through those points. All right. Is that an okay response there? All right. Can I leave it there and go on? Okay. Sierra, can I leave it like that and go on? Yeah. Is it different than yours? No? Are you sure? Okay, I'm looking at yours and I'm looking at that one, and mine's different than yours. It's different because she's actually finished the problem correctly by showing that it goes on forever, okay, where I didn't show that yet. Okay, so it's a line. The line does not stop, so you must put arrows. If you do not put arrows, you will not get full credit. Okay, you got that, Nolan? Okay, good. All right. Okay. All right. Okay, here we have the line with a slope of -3/4 that passes through the point 0, 2. So once again, we will graph the point first, 0, 2, and that is on the y-axis. So I have a y-intercept of 2. And the slope -3/4, the negative always goes with the numerator. It does not go with the denominator, just goes with the numerator. So that means I'm going to go down 3 and over 4. So down to -1 on the y-axis, over to 4 on the x, and so then I'll draw my line and add my arrows. So always put the point first and then the slope. And remember, now I've seen people do this. Remember, the slope goes from that original point. It doesn't go to the origin and draw the slope. Okay? All right, it goes from that point. Okay, intercepts. All right. We have things called x-intercepts and y-intercepts. What does it mean when I say an x-intercept or a y-intercept? Nolan? Okay, good. Where it crosses the x and y axis. So when we're looking for the y-intercept, x is equal to what? 0. And we're looking for the x-intercept, then y is equal to 0. Okay. All right, so y-intercept, x equals 0. X-intercept, y equals 0. So we want to find the intercepts and then graph this line. So the y-intercept, to find that, I will let x equal 0, then solve. Mm-hmm. Okay. Yep, Nolan says we're going to do the slope-intercept form next, and that is correct. Okay. So we divide by -2, and y equals -8. So the y-intercept is at -8. To find the x-intercept then, we will let y equal 0. So we get 4x equals 16. So x equals 4. And they put a caution here for you, just a reminder. The intercept is a single value, not an ordered pair or a point. And a lot of people like to do that. They'll say this is the y-intercept is 0, -8. No, it's not. It's just -8. Okay? They'll say the x-intercept is the point 40. Nope, it's just 4. Okay? All right, so we'll graph this. Y-intercept is -8. Put a dot on the at 0, -8. X-intercept is 4. Put a dot on the x-axis at 4, and then draw our line. I like the ease of my line drawing. They're always straight in this case. Okay, I want you to do this one. Okay, slope-intercept form. All right. Slope-intercept form is where we do y equals mx plus b. So if we have our equation or our function in that form, y equals mx plus b, then we can graph it. We can use the y-intercept, which is the value of b, and then the slope to graph our line. So one of the reasons why we practiced in the warm-up solving for y was for this reason exactly. So I'll take this equation, and I want to solve the equation for y. That's the first thing we're going to do. Now, when you write the equation, the order you put them in really doesn't matter, but I would always put the x term first and the constant last. That way you don't get the slope and the y-intercept mixed up. Okay. So we're going to add 4x to both sides here. Like I said, we'll always put the x value first. So this tells me that m is equal to what? 4? How about 4 over 1? Would that be better? Okay, because when I'm talking about the slope, when we're going to graphing it, okay, normally I don't need to put it right as a fraction, but if I'm graphing, it would be nice to have it as a fraction because when we graph the slope, there is a rise and a run, correct? And if I don't put anything on the bottom, okay, I don't know for sure, maybe I don't remember for sure what to do with it. Okay? And the value of b is what? -1. Okay? So my y-intercept is -1, so I'll put a dot on the y-axis at -1. It comes eventually. I think so, somewhere. Okay. All right. And my slope is 4 over 1, so I'm going to go up 4 to 3 and over 1 to the right. And then I'll draw my line. So there's actually two things happening here, okay? In both of these last two problems. They're asking us to write the function in slope-intercept form. So you have to do that, okay? And then graph it. In example 3, they said find the intercepts and then graph it. So you have to make sure you are doing those specific things, even if you have a favorite, okay? So maybe your favorite is slope-intercept form, and you do all your graphing that way. That's fine. But if it says find the intercepts, then you still need to find the intercepts for me, okay? Okay. So let's do one more. They want us to write this function in slope-intercept form and graph it. Okay. So we want it in y equals mx plus b form. So the y by itself, so we'll subtract x first. All right. Put the x term before the constant. Okay, so we have a fraction now in front of y that we need to get rid of. And Nolan says we want to divide by 3/4. Well, dividing by 3/4 is the same as, okay, multiply by the reciprocal. And you have to make sure You do it to everything, so make sure you put put parentheses, the 4/3 on the outside, and remember to distribute. So we get negative 4/3 x plus, what's 4/3 times 6?
Let's see, 1/3 times 6. It's 1/3.
Okay. And Kylie says it's 8. That is correct. 4 times 6 is 24. Divide by 3 is 8. Or 3 goes into 6 twice. 2 times 4 is 8. However you want to look at it. Okay, so when we graph this, we have a y-intercept of 8. So we'll put a dot on the 8 on the y-axis. Now our slope is negative 4/3. And once again, if you have a negative slope, that means we're going to go down, not up, and then to the right. So we go down 4, from 8 to 4, and over 3. So we have the point 3, 4 is where our other point would be. Draw our line, and make sure we have our arrows. Now, here's the thing to remember, too, is that especially when you're changing these to slope-intercept form, you should check a value, a point on the graph to make sure it works. Okay, it's not a bad idea to check it in every case you're working with.